Hello guys, ninjani? Esemba sinyapi. So this is the video I have promised you. So we are going to do an analytical geometry. Analytical geometry. You will find analytical geometry on question 3 of your paper 2. Is having 20 marks. We are going to do analytical geometry 1, which is more like grade 11 revision. So under analytical geometry, we are going to do the grade 11 revision. Grade 11 revision, which consists one of the distance formula, 2 the gradient formula, 3 the midpoint formula, number 4. We'll also talk about the angle of inclination, Number 5, we have to talk about parallel lines. Number 6, we're gonna talk about perpendicular lines. Perpendicular lines. Number 7, we're going to talk about collinear points. Number 8, we're going to talk about equidistance points. All right, I think we may talk about properties of quadrilaterals. Then we'll be done with our video. Let's consider, because everything that you are going to do here will be at a Cartesian plane. So you will be having some shape and this Cartesian plane, and these shapes are made out of lines, where the line will have x maps y and x maps y. You will have shapes in a Cartesian plane. You have to apply all these things because the shapes are made of lines. So a line is having two coordinates. Let's say this is x1, y1. This is x2, y2. Is a straight line, Ganzam. In this line, we can agree that the distance of y, the y value is being measured here. So the y value there is y2. And the y value here is y1. The x value there is x2. The x value here is x1. All right. If I may have this, it could be a right angle triangle. So in this right angle triangle, I am having this distance, which is y2 minus y1, which is y2 minus y1. This distance is y2 minus y1. I've said that you subtract the smaller one from the larger one when you want a vertical or horizontal distance. Same applied here. This distance is x2 minus x1. Let's say my other distance here maybe is AB. How can I find the distance of AB? According to Pythagoras theorem, the distance of AB squared is equals to this distance and this distance squared. So is equals to x2 minus x1 squared plus y2 minus y1 squared, according to Pythagoras theorem. So that means my AB will be square root of x2 minus x1 squared plus y2 minus y1 squared. So that is how you are going to find the distance between 2 points that are neither horizontal nor par nor vertical. Because when I'm looking vertical, I will say the larger minus the bigger. That is how you will find a distance of a line that is slanted. So let us continue. It is called the distance formula. Distance formula. Let's assume that we are having this Cartesian plane. Okay, in this Cartesian plane I am having this line. Okay, I am having this line. this line is x2, y2, x1, y1. I want to find the gradient of these lines, which means I want to find the slope or the change in y per x value. So I'll be looking how y changes, which means it's a gradient. I want to find the gradient of this line. So I'll be looking the change in y and change in x. So I will have m is equals to my y2 minus my y1 over x2 minus x1. We call this the gradient formula. One may say, if y can be, y is the graph, right? Let's say if y can be the value of the graph, I will have y minus y1 over x minus x1. If I can times this denominator both sides, if I can times this denominator both sides, here and here, I will have x minus x1 times m is equals to y minus y1. So my y minus y1 is equals to mx minus x1. So this forms the equation of a straight line. So when you are given a gradient and a single coordinate, you are going to use this equation to find the equation of that line, and the gradient is being found using this formula. So what about if I am having a midpoint here? How can I find the coordinate of m? Alright, m is between these two distances. Alright, m is between the two distances. How can I find the coordinate of m? The coordinate of m, which is the midpoint, could be this value plus this value divided by 2. So will be x2 plus x1 over 2 maps y2 plus y1 over 2. So I will get a coordinate here, and that coordinate is coordinate of m. Mind you that it is wrong to say m is equals to x2. It's not an equation, it's a coordinate. So coordinate is being denoted like this, maybe. Alright, then we call this the midpoint formula. if I were to have an angle here, you can see that I'm having this angle here. Where my x or my adjacent is the x values and my opposite is the y value. So my adjacent is this distance, and this distance is, we say if I am maybe I am having x2 or x3, then I'm having maybe x4. My distance will be x3 minus x4, which means here I will have, okay, let's say yes, I'm having x2, so I will have x3 according to my new coordinates, maybe now y4. I will have x3 now y3. Okay, this is the change. So this distance is y3 minus y3 minus y4, or minus y. So it's y3 minus 0, by the way, because it's work origin, unless if mhlambe singalibeka in another point. But you can see that this is the change in y, this is the change in x. So my opposite and adjacent, which means the tan, my tan beta can be my change in y over change in x, which means this is the gradient, right? This is the formula of the gradient, which means my tan beta is equals to my gradient. So this is the formula you are going to use when you're finding the angle of inclination. All right. Then what are collinear points? It's my points are collinear makwende njani. We are saying points are collinear if they are points that lie on the same straight line, which means if I am having a point here, another point here, another point here, maybe this is point A, B, C. We say point A, B, and C are collinear points because they lie in the same line, which implies that point A, B, and C are in the same line, which means the line here is having the same gradient throughout. Then if you are told that points are collinear, you use that idea that the gradient of AB is the same as the gradient of BC, which means if those points are collinear, the gradient of AB is equals to the gradient of BC, which is equals to the gradient of AC. You use that idea if you are being told that the points are collinear. And the equation of the gradient, which means we have yb minus ya over xb minus xa to be equals to yc minus yb over xc minus xb, which is also equals to ya minus yc over xa minus xc, which means if you are being told that points are collinear, you can use maybe the two. These points are collinear. Maybe these points are collinear. You use that idea. Alright. Let's talk about parallel lines. Parallel lines. What if you are having a Cartesian plane like this? Then you are told that these lines are parallel. AB is parallel to CD. If AB is parallel to CD, to me it implies that these lines will never meet, which means the change of this is equals to the change of that. So once you are told that if AB is parallel to BC, then the gradient of AB is equals to the gradient of BC. Alright, which means by finding one gradient you can find the other if those lines are parallel to each other. Then perpendicular lines. Let's have a line like this. And say maybe AB is perpendicular to B, to DC, to CD. If AB is perpendicular to CD, then the gradient of AB times the gradient of BC should be minus 1. Alright. This implies that whenever I am being given the gradient, maybe I am told that the gradient of AB is equals to 3 over 2. Then the gradient of CD. Then the gradient of CD will be the reciprocate times minus 1. You can write that statement down so that it will save you from calculations that one ends you marks. So you have to say you reciprocate. So reciprocate the gradient and multiply by -1. You reciprocate the gradient and you multiply it by -1. Even if it was -2 over 3, If I want to change it, we'll have 3 over 2, right, times minus, so I will have positive 3 over 2. You reciprocate it times by negative 1. Alright, or you reciprocate it to change the sign, symbol like that. Then we have to talk about, we have done this. Then let's talk about equidistance point. When they say that point is at equidistance, what do they mean? All right, let's have a shape like this. This is just, I've never said is a parallelogram. Let's say I'm having this shape, then I'm having a point maybe here. It's not that always it will be inside. Maybe it's point E. If point E is at equidistance of A and B, then AE is equals to BE, which means the distances are equal. If this point is at equidistance of this, then these distances are equal. So when you have been told that a point is equidistant from blah, you use the knowledge that the distance of the point from that particular coordinate is equals to a distance of the point from the other particular coordinate. So equidistance, they are talking about the distance. So here you use distance formula, idea of distance formula. Here you use the idea of the product, that is -1. Here you use the idea that the gradients are the same. All right. Here you use the idea that the gradients are equal. All right. Then we're gonna talk about